So in this last section here, let's look at acid-base behavior and chemical structure. So what we can say about this is the following. Any molecule containing a hydrogen is potentially an acid. But many such molecules showed no acidic properties. Some examples of this are CHCl3 and CH3NO2. In these cases, the CH bond is very strong and nonpolar, and there is no tendency to produce H+. So when we look into how acid strength can relate to chemical structure, there are two factors that determine the acidity of an XH bond. Okay, number one is the polarity. The more polar we observe, the stronger the acid. And number two is the bond strength. And both of these factors have to add together. And it's not, we can't just look at one and not the other. For example, if we compared HF versus HCl versus HBr versus HI, let's look based on polarity. We would predict that HF should be stronger than HCl, which should be stronger than HBr, which should be stronger than HI. Okay, but in reality here, HF is a weak acid. So based on bond strength, we observe that HI is greater than HBr, which is greater than HCl, which is greater than HF. And the actual observed order is going to be a combination of the both. So we have HI being greater than HBr, which is greater than HCl, which is greater than HF. And here, notice that these guys right here are strong acids, where HF is weak. And we're going to look at these and we're going to see a combination of two factors that are polarity and bond strength that will influence the strength of our particular acids, and we can relate that to chemical structure. And in the next video, we'll look at the structure of oxyacids and determine the strength in the same fashion.